Hello students, today we are covering lesson 10.7 on comparing populations, so follow along in your textbook on page 450, please. I would like you to copy down the vocabulary, and this is important because some of the vocabulary is not in your textbook, so I need you to make sure you copy this down. The first word is mean absolute deviation. Sometimes it's abbreviated MAD, or MAD. It's used for symmetric or evenly spread out distributions of data. So we're going to be comparing different populations of data. And if the data is evenly spread out, we'll find the mean absolute deviation to compare those populations. So here are the steps to find the MAD. First, you need to find the average or the mean of all the values in the set. Next, you find the distance of each value from the mean. So you subtract the mean from each value. Remember, distance is always positive. So you find the average, then you subtract each value from the average. And step 3, you find the mean of those distances. So then you find the mean from step 2, and that becomes your mean absolute deviation. So pause the video and finish copying down those 3 steps, please. The next vocabulary word is interquartile range, or IQR, and it's used for skewed data distributions, data that is not evenly spread out. To find the interquartile range, number 1, you put the numbers in order from least to greatest. Step 2, you find the median, the number that's in the middle. If there are 2 numbers in the middle, then you find the average of those 2 numbers. Quartile 1, or Q1, is the median of the lower half of the data, and Q3, or quartile 3, is the median, the upper half of the data. And the last step is to subtract quartile 1 from quartile 3 to find the interquartile range. Pause the video to finish copying this down, and I will explain each of this in the next example. So example 1 is comparing populations. The double dot plot, as seen here, shows the time that each candidate in a debate spent answering each of the 15 questions, and the time is in seconds. So candidate A is blue, candidate B is red. Here's the time in seconds. So you can see 30 seconds, 40, 50, 60, 70, and so on. Compare the populations using measures of center and variation. So looking at the data, we can see that the data is pretty evenly spread out. It looks symmetric. So we're going to find the mean absolute deviation. First, we need to find the mean. So for the blue values, I'm going to add up each of the 15 numbers. So we have 50. We have 2 60s, 2 dots on 60, so it'd be 60 plus 60. And then you have 2 70s, 3 80s, 3 90s. Oops. There we go, getting caught up. 1 100, 2 110s, and 1 120. So you add up all 15 numbers, and when you add all those numbers up, you can double check my math, you get 1260 for the total, and you divide by the 15 numbers we've added to find the mean, and you get approximately, or exactly, 84. So the average time they spoke for candidate A is 84 seconds. Now to find the mean absolute deviation, what you want to do is you want to find the distance of each one. So we're going to subtract 84 from 50, the first number, and you get 34. Then we're going to find 60 from 84, which is 24. So you're just finding the difference from each point. Go ahead and you can continue that on your own. Again, you divide all of those by 15, and you get a total of 16, or approximately 16, it's estimated. Same thing for candidate B. I'm going to skip ahead just to save time. You would add up all 15 values. So 3 30s plus 40 plus 2 50s plus 4 60s plus 2 70s, 80, and 90. And then when you add all of those up, you should equal 870. I would like you to try it. Just for the video's sake, I'm going to skip ahead to save time. Divide by your 15 values, and that gives you an average of 58. So to calculate the mean absolute deviation, this time we're looking at each value and subtracting it from 58. So 58 minus 30 3 times. So that would be 28 plus 28 plus 28, or 28 times 3. And then 40 from 58 is 18. And you would do that with all 15 values, divide by 15. And this time you get the mean absolute deviation is also 16. So the variation in times was actually about the same. They both varied by 16 seconds. But candidate A had a greater average time. Now for part B, to find the difference in the measures of center for both candidates, we're going to subtract the mean from candidate 1, which is 84, minus the mean for candidate 2, which is 58, and divide that by the mean absolute deviation. And when you calculate that, you get 26 divided by 16, which is 1.6. So the difference in the means is about 1.6 times the absolute deviation. I would like you to try number 1 on your own now. Number 2, you're comparing two populations with a box and whisker plot. Pardon the bell. You want to compare the cost of the speeding tickets in 2 states. So you have a double box and whisker plot here for 10 speeding tickets. Now to compare, this time you see the data is very skewed. It's very spread out and it's not very consistent or even. So what we want to do is we want to find the median. The median is the number here in the middle. So if you look in the box and whisker plot, it's the number inside the middle of the box. The median for state A is 70. That's the cost of the ticket. And the interquartile range is the range of the box here. So 80 minus 60, so that's a range of $20. Now to compare state B, the median is 80, and it's also in dollars. And the interquartile range here ranges from 70 to 100, which is a difference of $30. So if we wanted to compare both distributions, they are both kind of skewed to the right. And so we found the mean, or the median, and the interquartile range. The median and the interquartile range are pretty similar. However, the sample size is too small because they only have 10 speeding tickets. For B, the double box and whisker plot shows the medians of 100 random samples, which is a much larger sample. So now we have more to compare. If we compare the medians, then there's much less of a difference. So this is a better sample because there are more speeding tickets. There's 100 of them. Now to make a conclusion, the sample of the medians shows less variability. So most of the sample medians for state B are greater than the sample for state A. And you can see the higher price here for the 2 costs. So I just wanted to review that with you. We'll spend more time on it in class tomorrow. Right now, I'd like you to try on your own number 2. And that's it for today. I hope you have a great day. I'll see you tomorrow. Bye-bye.